In section 7 of unit 4, we're going to take a look at expected value and simulation. Now, as we look at number 1, 5 fair coins are tossed. Find the number of heads. Well, every time you toss a coin, there are 2 probabilities, and that you're going to toss heads 5 out of those times. 5 out of 2 equals 2.5. Now, this is the shortcut way of doing it, because if you had 5 coins, how many times would you expect it to be heads? Well, half of the times. So half of 5 is 2.5. Now, if you toss 6 coins, just from background, and there's 2 sides, half of the times that would be 3. And we did something like this in our flipped classroom with the number of boys, number of girls, but we went through a tedious process of working that out. This is the shortcut way. Let's go on. Now, for example 2, we're going to have to set this up in some form of table here, where we'll read this carefully and then develop an expectation. So part of the help on this is how to set it up. So we're going to roll a die, of course, and it's 1 through 6. Well, if you get a 6, you earn $6. If you get a 5, you earn $3. If you get a 4, you earn $2. And you have no payoff for these others. Now, they're not telling us how much it would cost to play the game, but just what would be the expected winnings. So let's figure that out. So something like this. So for these, there's no expected winning. Here, this is going to be 1 out of 6 times 2 is 1/3, and the decimal form of 1/3 is this. 1/6 of the time we're going to get a 5, and the winning is $3. So 3 out of 6 is 1/2. So that would be this in winning. And then 6 out of 6 is a 1. Again, this is 1/6 out of 1 is 1. And added up, our expected winnings for this type of profile is $1.83, rounded to the nearest hundredth. Now, for example 3, again, I'll help you set it up similar to the previous example. Here are the number of complaints per day a used car dealer expects. So 0, 1, 2, 3, 4, 5, 6. But the probability of these are indicated by these numbers. So take a moment in your notebook for example 3. Going to produce this little chart, and then you're going to produce this next to it. For 0, it's 0.01, and copy these down. Then we'll get to our next step. Now, the next step in expected value is to multiply this column by this column and see what you get for each of these. And a question might be too, what would this column, which is probability, add up to? Well, this should add up to 100%. All right, let's go on. Now, when we do this, this is the results, but what do the results mean? Well, it's your answer that you're going to put, let's put that properly here, 2.61 complaints per day. And it says, do not round your answer. Now, if you're going to get these many complaints, and these were the probability that you would get these, then the expected value per day would be the weighted average, in the sense of this, depending on its probability. Now, in our next section, we're going to do things like this. Just look at it perhaps a little different way. All right, let's go on. Now, in example 4, it's a similar example, and what we want you to do is figure out how to display the data. So number 4, you're going to have families in a park, and this will be the number of children. And how many families had that number of children here? So let's put here, instead of a W, let's put F for families. And then out here we'll have the value. So we have families with no children, families with one child, 2 children, 3 children, 4 children, 5 children, and 6 children. So we're helping you create a little chart to record your data. And we're doing it together. And all of this takes time, of course. Now, how many families do we have that, let's start right here, had brought one child? So this is 1410. 2 children, 2170. This brought 3. This brought 4, 1850. 5 was 900. 1,000 brought 6 children. They must have had neighboring children there too. And 400, no children. Now here we want to find the expected average of number of children per family. So in a sense, this is a weighted average. So we're going to multiply the number of children by the number of families. So here this is 0. This is just going to be 1410. Then we're going to go 2 times this, 3 times this, 4 times this, 5 times this, 6 times this. Now, once we get a grand total, how many families were here represented? And the answer was 10,000. So we're going to take this grand total and divide it by 10,000 to get a weighted average. All right, let's go on. So in analyzing the results here, when we did all of this tabulation, we got that there were 30,460 children in the park, and there were 10,000 families. So we take this divided by the 10,000, and we get this as an average. Now, they want us to round to the nearest tenth. Well, the nearest tenth is 0, but we go to the hundreds place. This is a 4. If it were a 5, we drop it and add 1, but since it's a 4, we're just going to drop it. So the answer here is 3.0 children average per family visiting that amusement park. And you see, it did take a lot of time to do the calculations to get the answer. And we don't have too many examples in this section, but a few more. Let's go on. Now, as we look at example 5, what we're checking out here is how to set this up. And I'll give you some help on this. So in a certain city, projections for the next year indicate a 20% chance, so that's probability, that the jobs will increase by 1,300. A 50% chance they will increase by 300. And a 30% chance they will decrease. Notice that. That's a negative 900. So again, similar to what we've been doing, we want to find the expected job values for next year. So again, you're going to multiply through, add up, and see what you get. So moving these values over here, we get 260. This times that is 150. But 0.3 times a negative 900 is a negative 270. So when we add these two, we get 410. Subtract 270 from it, we end up with 140. The expected change is an increase of 140 jobs, and this was the protocol we used to get there. All right, we'll do one more. Now, we worked one like this in our flipped classroom lesson, and a promoter is going to have an outdoor concert, expects to earn $100,000 unless it rains, sort of like the wheat harvest. Now, if it rains, his net profit would be $35,000. Now, the probability of rain is 40%. The premium for insurance is $25,000. And the coverage would pay him $100,000 in the case of rain. Find the expected net profit when the insurance is not purchased. So again, you're going to need to do some thinking about this, and I'll set it up here too to see how you did. So once again, this is expected net profit. Well, if it's the probability of rain is 40%, the probability of not rain, the complement, is 60%. So 60% of 100,000 is 60,000. Now, 40% of 35,000 is 14,000. So his expected profit is going to be this plus this, or 74,000. Now, keep in mind, in the real world, if it doesn't rain, he's going to earn 100,000. But again, expected profit, and this is what some people do, think about various possibilities. But remember, if he buys insurance for 25,000, he's going to get, if it rains, 35,000 plus the 100,000 from the insurance. So he's going to get 135,000 less 25,000. So he's going to make 110,000. So the good deal, as I see it, is buy the insurance. Okay, now if it doesn't rain, of course, then he only makes 75,000. But it's still better than not buying the insurance. Okay, one more lesson after this. This wraps up this one. And I guess we did them all, didn't we? But you could expect different numbers for your homework. And that will be included as part of your homework grade.